Welcome to Intermediate Algebra, Unit 3, Lesson 1, Graphing Equations with Two Unknowns. We've been working with one variable, single variable equations and inequalities to this point, and graphing them on a number line, which goes just left to right. Now we're going to look at what happens when we have two variables and we graph in two dimensions, left, right, and up and down. Our lesson objective is to graph a linear equation. A linear equation is any equation that has either an x to the first power or a y to the first power or both, and no other variables and no other exponents, but has some multiplication, addition, subtraction involved maybe. But we're going to graph linear equations with two variables, and we're simply going to do this by plotting points. You pick a number and replace one of the variables with that and find out what the other variable becomes by solving the equation and graph that as a point. So, when we represent a two-variable equation on a graph, we need two dimensions. Now, in prior lessons, we've looked at things like graphing x equals 6, and you have a number line, and you have a 6 on it, and you would fill that in. Or x greater than 6 or equal to 6, you would fill in everything to the right, or you could do it right on the line. But what this filled-in space represents is all the solutions, that all the points that make that true, where 6 equals 6, or in the case of the inequality where 6 is greater than or equal to 6. So now we're going to look at, this is the most simplest linear inequality. All the y coordinates are going to be the same as the x coordinates. Okay, so y equals x. That means if x equals 1, y has to be the same. So I would graph the point. Now for the x, I start at the middle here, okay? I start at the crosshairs, I start what we call the origin. And then I move to the right one for x is a positive 1, and up 1 for y is a positive 1. So x controls left and right, and y controls up and down. And similarly, if I let x equal 5, y would also have to be 5, because my equation is y equals x, or y is always the same as x. So I go over to where x is 5, and then I go up to where y is 5, and I get a point. Now, if x equals negative 2, y will also equal negative 2. Now, if I have a negative for the x, I move to the left, so I go over here. And then I move down 2 for the y coordinate being negative. And hopefully that isn't news to you, that's just a refresher. And then I fill in my line, and that's approximate. So that is all of the points on this line represent places where the y and the x coordinates are the same, where y equals x, where this equation would be true. So here's one where the coordinates are not the same, but if I know an x coordinate, I certainly can, oops, sorry, I went back a couple here. I need to go back. Well, so I have y equals x plus 3. So I'm just going to choose some values for x. Let me choose x equals 0. That's always a good one to try. So that means y equals 0 plus 3, which is 3. So I get the point 0, 3. And we often do this calculation, but we set it up in a table. Make a table of points. Sometimes you'll see this. And when x is 0, y is 3. That just means I'm going to graph that point. So when I graph the point 0, 3, I don't move left or right because x is 0, but I move up 3. So there's the point I would graph at 0, 3. Now, I pick another value for x. If I pick x is 1, y is going to be 1 plus 3, because the equation is y equals x plus 3, and x is now 1, and I'm going to get 4. So for that one, I would graph, I would go to the right one from the start of the origin, go to the right one, and go up 4, and I'll get that point there. Let's pick x equals negative 4, just to show you can pick negatives. Negative 4 plus a 3. Now, when I add signed numbers and the signs are different, I basically subtract. So 4 minus 3 would be a 1, but I keep the sign of the bigger value. 4 is a bigger value than 3. So I get a -1. So I graph the point -4, -1. So I'm going to move to the left 4 and down 1. And that puts me right about there. Now, I really only needed 2 points to find a line, but finding a third one just kind of confirms that I'm on the right track. And these arrows represent that this goes on forever in both directions there. So any point on this line, or that would be on the line if I continued it, is a point that would make this equation y equals x plus 3 true. Next example is in a different form. This is still a line because you don't have anything with exponents on it besides a 1. There's an x to the first and a y to the first. And you only have x's and y's. You don't have them multiplied together or anything. So this one, it's often most efficient to graph by using x-intercepts and y-intercepts. And the x-intercept is where y is 0. Where I intercept the x-axis. So any point on this x-axis here, if I pick any point here on the axis, the y-coordinate is going to be 0 because the height is 0. You don't move up or down from the origin. And for the y-intercept, to find out where the graph crosses the y-axis, it's any point on this y-axis here, you'll have an x-coordinate of 0 because to get there, you started at the origin, but you didn't move left or right at all. So that's why for y-intercepts, x is 0. So we use this information, and we're going to put in x equals 0 to our equation and put in y equals 0 to our equation to get our 2 different points. So I'm going to let x equal 0. And that always confused me. How can you just let it happen? Well, you pick the number for x you want. You could let x equals 1 and solve. You'll get a point that will be valid. But if I let x equal 0, what happens is this 3 times 0 plus 5 times y equals 15 simplifies because 3 times 0 is 0, so it might as well not be there. It's just added. And I get 5y equals 15. Well, that's one variable. That's easier to solve. And I get y equals 3. So I have the point 0, 3 to graph. So when I graph the point 0, 3, and I'm going to erase this and then graph it, x is 0, y is 3, would be graphed right there. So for the next point, when my equation's in this form, or when your homework says graph using intercepts, this is what they mean. They mean let x, put in x is 0 and find y. And then for the next one, you put in y equals 0 and you find x. So you get 3x plus 5 times 0 equals 15. You don't just have to choose x coordinates to graph. You can choose the y coordinate and find the x. When our equation is in the form y equals already, it's easiest to choose the x, but in this case, it isn't. So 5 times 0 will be 0, so you get 3x equals 15. Divide both sides by 3, you get x equals 5. So the point is 5, 0. I go to the right 5, and I don't go up and down at all. So there we are. 2 points fully determine the line. You could pick some other values if you wanted to make sure they lined up, or were what we call collinear. But when you're asked to graph by plotting intercepts, this is what you are being asked to do. So now we have y equals -5x plus 2. A little difference is some sign number arithmetic introduced here. Oh, I went ahead a slide, sorry. Keep doing that. So y equals -5x plus 2. This one's already solved for y, so the easiest way to do this is pick some x's. And I'm going to show this one in a table, because often that's the way you're presented things or see things. So, and here, so here's how I'm going to find the y once I pick an x. I'm going to do -5x plus 2. So 0 is always a nice number to pick. -5 times 0 plus 2, that becomes a 0. I just simply get a 2. That's the y-intercept. That's always a nice point to graph. Then you really only need to pick one other point, but you could pick 2 other points. I'm going to just let x equal 1. So I get -5 times 1 plus 2. I have a negative times a positive, so that gives me -5. When the signs don't match, you get a negative number, plus 2. I'm adding numbers with different signs, so I subtract them. So I would get the difference between 5 and 2 is a 3, but the 5 was bigger, so my answer is a negative 3. And then let's pick x equals, negative 2. So if I put in x equals negative 2, I get negative 5 times negative 2 plus 2. Here the signs match and I'm multiplying, so I get a positive 10 plus 2, I get a 12. Now that's going to be a little bit off my graph, so I might want to pick something different, but let's just work with that and see what we would do in that case. You already have 2 points, so it's okay. 0, 2 will be right there. 1, negative 3 will be right there. And then I would have negative 2, 12. Well, 12 is going to be off here somewhere. It's going to be up a little bit higher than my graph will show me, but I can see that that third point would be approximately in a line, and that's really bad line. You should use a ruler to draw your lines, unlike I just did. But so there's another example of graphing a linear equation. So we go to the next one. This is one where I have the form where I might want to try x is 0 and y is 0. So let's try x equals 0. I get 2 times 0 minus 5 times y equals 8. Negative 5y equals 8. Divide by negative 5, divide by negative 5. So I get y equals negative 8/5. Now in a fraction, if there's one negative and it's on the top or on the bottom, you can just put it out in front. You might want to turn this to a mixed number. That's negative 1 and 3/5 more to the left. So when x is 0, I'm going to go down negative 1 in just a little bit. Well, a little more than halfway. 3/5 is a little more than half. So right there. So this doesn't come out to nice round integers to graph. So you need mixed numbers are helpful in graphing. Or you can pick different values for x that you could just pick x as 1 and see if that helps you get a better number, or pick x as 2, pick x as 3. But really, don't avoid fractions all the time. That you should be able to use them. So that's my x is 0, y is negative 3/5. And now I'm going to do this over here so I don't have to erase the rest. If I let y equal 0, I get 2x minus 0, because 5 times 0 would be 0 equals 8. I do get x equals 4 for this one. So x equals 4, y equals 0 will be right about there. There's the equation of, there's the graph of my line. Okay, you try this one. And then there's several other you try it. You can stop, try one, and then come back. Okay, so you've stop the video, try to graph this one, and then come back and see what my graph looks like. Okay, so I picked x equals 0, and then I got y equals 5. And if I pick x equals 2, I get y equals negative 4 plus 5. I get y equals 1. So 0, 5, and 2, 1. Your graph should go in this direction, which you'll learn soon. You can tell it would be because of the negative 2 in front of the x. And should be about like that. Now let's move to the next one. The next you try it. So let's graph 3x minus 2y equals 12. Stop the video, try it, and then come back. Okay, you're back. For this one, I do this one with intercepts. X equals 0. That will give me 0 minus 2y equals 12. So y is going to equal negative 6. So I have the point 0, negative 6. Point 0, negative 6 would be right about here. And then when I let y equal 0, I get 3x. The minus 2y term goes away because it'll be 0 equals 12. And that gives me x equals 4. X equals 4, y is 0 is about there. And that's my line. You should have something like that. And for the last one, let's try this. Okay, you're back. I let x equal, oh, I'm on the wrong slide, sorry. So I let x equal 0, and I get 0 plus 3y equals 9, so y is 3. That gives me the point 0.03 right there. And when I let y equal 0, I get 2x equals 9. X equals 9 halves. That is 4.5. So I go halfway between the 4 and the 5, and I don't go up at all because y was chosen to be 0. And my graph looks like that. If you did not get these graphs correctly, you should try them again. You should email me. You should go to the tutoring lab. You should find your mistake or get help. Don't just say, oh, I didn't get that. Okay? And let's see. I think that's it. Yes, that's it. So thank you for joining me for this edition of Math Teacher to Go. Please follow up by getting help on those things you did not understand and go do your homework.